This is our first video on strings. So we've seen strings before as a data type. So we've used it where you could just basically say something like string name is equal to Bob. And we've done this, and then we've been able to see out a string. Okay, so that's what we've done so far with strings. And in addition to acting as a data type, strings are also a data structure, which means they're a way to store information. So we've seen arrays so far, and arrays are also a data structure. Okay. So using strings in this way is a little bit different, but it's a very powerful tool. Lots of programs require this technique, or at least they're made easier with it. Okay. So when we say strings, we're talking about uh, the strings that are built into the standard library of C++. Okay. C was the predecessor language to C++, and it didn't have strings. It instead had character arrays, or C strings are sometimes called. Okay. So we'll talk about those in another video and later in the chapter. But for this introductory video, we're just talking about regular strings. Okay. So it's important that strings and chars are different. Okay. So a string here, we can call it a sequential data structure or uh, just call it that's it. A sequential data structure makes no sense. Or a linear data structure. It's just a one-dimensional thing. Okay. But it's strings are enclosed within double quotes. Okay. Now back in Python, we could do either one, but you can't in C++. Okay. So within these quotes, you can have spaces, you can have numbers, you can have exclamation points, whatever you want. Okay. So you have a lot of flexibility with what's between the strings. Okay. The only issue you have is if you want to put a double quote within the string, and then you can do that. We'll talk about that in a later video. Okay. But for now, we're just keeping it pretty basic. Okay. So again, a char is different in that a char holds a single character. Something like that. Okay. And chars are interesting, and we'll need to talk about them because a string is a sequence of chars, really, which we'll see in a second. But chars are a numeric type, which seems strange. There's a lot that goes on behind the scenes in that it stores an integer, a small integer that relates to the ASCII value. So the ASCII is the American Standard Code for Information Exchange. It's basically a way to turn um, bit patterns into characters we would understand. Okay. So, for example, an A is 65 in ASCII. Okay. So that's why the char types are numeric and can be used as such. You can add to them, you can subtract to them, things like that. Okay. So they're not the same thing. So they have the single quotes. You can't interchange them. Okay. But one of the things that we haven't done yet with our strings is to deal with individual characters of the string. And we can do that. So I could say something like character C is equal to the name string at position 0. Okay. Just like we did with arrays. Okay. And then that would be equal to the capital P. Okay. So let's talk about some characteristics of strings we may not have talked about before. We haven't may not have mentioned before. The first thing about a string is that it has its dynamic sizing. So this isn't like an array. We don't have to declare how big the string is going to be, okay, before we start. So I could set my name equal to Bob, which takes up 4 characters. And then I could set the name equal to something really, really long, okay? And it will dynamically allocate more memory for the string, okay? Which is an important thing. Okay. Again, we can do the character access, which we just did. We can get to each individual character. Okay. An important concept that we'll have to deal with, we're talking about data structures, is this concept of immutability. Okay. To say that something is mutable means you can change it. So arrays are mutable. Okay. If I have an array, okay, so let's say I have an integer array. Um, if I can type correctly, it's early. Something like this. Okay. then I can certainly say that A sub 0 is equal to 11. Okay. Perfectly okay, because arrays are mutable. On strings, I can get to name sub 0, but I can't say that it equals something else. Okay. C if it's Cobb instead of Bob. Okay. This is not allowed. Okay. This would violate the immutability. Okay. But where students are often confused, I can create a new string. Okay. So I can say, like I just did, name is equal something bigger, and that is not violating the immutability. Okay. So immutability is not the same thing as constant. Okay. So we can change the entire string. We can't change parts of the string. Okay. So we'll see later, we can create a new string based on the old string. That's perfectly okay as well. Okay. So in addition to that, we also have the ability to do comparison operators. Okay. So if I have a string name, let's say we have name 1 equal to Bob. We have string name 2 equal to Alice. Okay. Then it makes sense to do things like if name 1 is greater than name 2. Okay. And we're going to evaluate that. Do whatever. Need something in there. Okay. It's going to evaluate it based on what is called lexicographical order or dictionary ordering. Okay. So in this case, the value, it turns out in ASCII, the value of A is the capital A is 65. Okay. So it would start what it's doing behind the scenes when you do this. Okay. You don't have to do this. It's looking at name 1 sub 0, comparing it to name 2 sub 0. Okay. In this case, name 1 sub 0 is 66, and there are ASCII tables you can look up to determine that. And name 2, name 2 is 65. Okay. So you're asking, is 66 greater than 65? And in this case, it's true. Okay. So this would evaluate as true. Okay. If they were both the same first letter, it would continue on until it found a difference. Okay. You can also talk about equality. Is string 1 equal to string 2, not equal, greater than, or less than, all those. All the comparison operators work. Okay. So that's certainly something that we can do. Okay. So other characteristics of strings is, and this will make more sense the further along we get. It's the idea that there's a built-in copy constructor. Okay. So we have to worry about this thing called aliasing, where two variable names point to the same place in memory. It's a problem because changes to one can be reflected in the other in ways we don't expect. Okay. But we don't have to worry about that with strings. Okay. So with the strings, I could say something like string name 2 is equal to name 1. Okay. That's using the assignment operator, the equal sign. That's the copy constructor. We now have a new variable name 2 with its own memory space that now contains Bob as well. And changes made to name 2 will not affect name 1. Okay. And then, of course, we can use the CN and C out just like we can for anything else. Okay. So, for example, if I do a C out here, um, what is your name? Sure, there's space there, and then I can CN name 1. Okay. Works just fine. No problems there at all. Okay. So again, just one last thought about immutability there, just so you won't be confused. Um, I can rename a string at any time I want, and that's creating any string. So I could say name 1 is equal to something else, and that is perfectly okay. That is not violating immutability. Okay. So one of the things we have not done that's a powerful tool sometimes is that we can iterate through a string. Okay. So just like with arrays, so we can do a for loop here. Okay. But before we do that, let's think about how we're going to know how big our string is. Okay. So for that, we have two things, and we'll go ahead and just, we can see out that I'm not compiling things, but you get the idea. For my string name one, I can say name one dot size. Okay. And that would return 3. I could also say name one dot length. Okay. Exactly the same. We'll go ahead and compile this one just to keep us honest. Only if I can find my cursor. The new Zoom does some weird things sometimes. Okay. Okay. And you see those are both 3. Okay. Why they're 2, don't know. It doesn't make a lot of sense that there are 2, and I don't like that there are 2. So go with 1 and stick with it so you don't have to remember it. To me, size makes more sense because we were using size with our arrays, but whatever makes you happy. Okay. So once we have that, then we can now go through our string one by one. Okay. So for int I equals 0, like we do for our arrays. Okay. I is less than name one dot size. Okay. So again, unlike arrays, strings know how big they are. Okay. And again, because they have to, because of that dynamic allocation of memory. Okay. And then we do an I plus plus. And then we can go through and see out name one sub I. Okay. So if we do this, I haven't made a typo, which is never a guarantee. It's just going to print out the letters one by one. Okay. And of course, we could do other things. We could put tabs between them, whatever you want to do. Okay. So that's an important technique we're going to use a lot. Okay. Something else that we can do, or kind of a new way to do this, there's a modern style for loops that I think looks a little bit more Python-like. Okay, because remember, a for loop in Python is not an iterator, a, a general counter. It's more like iterating over some data structure. Okay, so we could say if we wanted, and I like to show you this. I won't use this in class, but if you see it somewhere, just so you understand what it means. Okay, so we could say for char whatever ch, and then whatever the name of our string is. Okay, then that's going to pull out that character. Okay. And that should work exactly the same way. Let's double check to make sure it does. Yeah, it does exactly. Okay. So no real difference there. Just a different, it's more, again, more um, of a Python-like view for that. Okay. And again, this, we don't have to worry about this character CH hanging around because once we're out of here, it's gone. Okay. So that's important. Okay. So the last thing that we can do that we're going to talk about today is this idea of string concatenation. So concatenation is just a fancy word for combining things together. Okay. And we can do this with the plus sign. This is, again, we can do this in Python as well. Now, what we can't do in C++ is do the multiplication symbol to repeat a sequence of characters. That doesn't work in C++. That'll give you an error. Okay. So, for example, if I have a string C is equal to cats, and a string D is equal to dogs. Okay. I can create a new string. String S is equal to C plus D. Okay. And then I can see out S. This is probably not really what I want, but we'll see what it's doing here. Okay. So if I run this, cats and dogs are right there together. Okay. So remember, I can concatenate 2 or more strings. So I can put in a string, even something like and plus. Okay, now that may make more sense for us as we go through. Yep, cats and dogs. Okay. So note that we can also, we're going to see this a lot in programs. We can build a new string based on the old one, okay, using the plus or the plus equal, either one, okay? And that seems like, again, that we're going to be violating immutability, but we're not, okay, because we're creating a new string. So I can, for example, say name is equal to Bob, okay? And then I could say name is equal to name plus space Smith, okay? And then C out name, okay? This will work just fine, except I have to initialize it as a string. Okay, that works just fine. So again, that does not violate the immutability. Okay. And one thing that you've seen me do in class a couple times, instead of saying name equals name plus, we can just do a name plus equal. That's exactly the same thing. It's kind of a shorthand. But in addition to being shorthand, it's also more efficient, okay? Because it requires the CPU to make fewer temporary objects, basically. Okay. So either one works, but this one will be more efficient in the long run. Okay. And that's it to our introduction to strings. Okay, so strings are very powerful. In the next video, we're going to talk about some things, some functions from the string library, because we mentioned it briefly in our built-in function section, but we really hadn't gotten to strings, so we didn't do it. So there's lots and lots of built-in string functions in the string library. Okay, so we'll talk about those. Okay. Um, and then we'll also talk about C strings and maybe even talk about string streams, okay, which are another advanced topic. Okay. So that's it for this video. As always, if you have questions, make sure that you let me know.